Good day. We are your general math teachers for today. And I am Sir Mark Christian Nazareno. As grade 11 students, one of the first lessons that you will be having is functions and underfunctions. You will have the composition of functions. Let's have a quick recap on functions. As defined in the OmniKit, a function is a relation where each element in the domain is related to only one value in the range by some rule. A relation is a rule that relates values from a set of values to a second set of values. Just like humans, numbers and values have relations too. To make things short, a relation is called a function whenever the domain does not repeat itself, or when it does not relate itself to more than one value from the range. For example, in this picture, you can see the one-to-one relation. The domain is the set of values found in the left column. In this case, you can see that the domain is only related to one value from the range. Thus, this is a function. In this picture, you can see the many-to-one relation. In this case, you can see the range repeating but the domain does not repeat itself. This means that the many-to-one relation is a function. Take note that all functions are relations, but not all relations are functions. Now, let's move to composition of functions. What is a composition of functions? As defined by Wikipedia, function composition is an operation that takes two functions f and g and produces a function h such that hx equals gfx. In simpler terms, when you are given two functions, say for example functions f and g, the composition of functions is when you will compose function f with function g. It is denoted by f circle g. This is read as f circle g. It is defined by the equation f circle g multiplied by x is equal to f times the quantity of g multiplied by x. In this equation, f is a dependent function and g is an independent function. For example, find the composition of f with g when f of x is equal to 5x minus 3 and g of x is equal to 3 minus 2x. In order to solve this, the first thing that you will be doing is writing down the equation. Write down f circle g multiplied by x is equal to f multiplied by the quantity of g times x. Substitute the f multiplied by the quantity of g times x with the value of f of x. After substituting, replace all the x's in the dependent function or the f of x by the expression of the independent variable of the g of x, making it look like this. All there's left to do in order to solve this equation is simplifying. Let's simplify this step by step to avoid confusion. Distribute 5 in all the terms of g of x. It will look like this when you distribute it. The arrows in distributing means multiply. So you multiply 5 by 3 and multiply 5 by negative 2x. After you distribute, you will get 15 minus 10x. The last thing to do in simplifying is combining all the like terms. In this case, the only like terms are the constant terms or the terms with no variables. The constant terms here are 15 and negative 3. It is important to always include the sign of the term, because it can greatly affect the result once you are solving. You combine 15 and negative 3 by subtracting 3 from 15. Therefore, The composition of f with g is negative 10x plus 12. Another example. Find the composition of g with h when h of x is equal to 1 over x and g of x is equal to 3x plus 5. In order to solve this, the first thing that you will be doing is writing down the equation. Write down g, circle h multiplied by x is equal to g multiply the quantity of h times x. Substitute the g multiplied by the quantity of h times x with the value of g of x. After substituting, replace all the x's in the dependent function or the g of x by the expression of the independent variable of h of x, making it look like this. The next thing that you will be doing is distributing 3 to the value of h of x, which is 1 over x. You can properly distribute it by multiplying it to the term inside the parentheses. So you multiply 3 by 1 over x, making it 3 over x. Since there are no like terms in this equation, it is safe to say that this is the simplest form. Therefore, the composition of g with h is 3 over x plus 5. Find the composition of q with g. When the q of x is x squared minus 2x plus 2 and the g of x is square root of x plus 1.
First thing to do is write the equation q, circle g times x is equal to q times the quantity of g multiplied by x. Substitute q multiplied by the quantity of g times x by the value of g of x. After doing this, substitute all the x's on the right side of the equation with the value of g of x, making it look like this. The next thing to do is simplify. In order to simplify the first term, you can eliminate the radical symbol because outside the first term's parenthesis is a squared sign, making it possible to eliminate the radical sign, leaving you with x plus 1. On the second term, you can distribute 2 since the term inside the parenthesis is also inside a radical sign, leaving you with 2 square root of x plus 1. The last thing you need to do is to combine all the like terms. In this case, the only like terms are positive 1 and positive 2. Negative 2 is not considered a constant term because it is a part of negative 2 square root of x plus 1. Therefore, the composition of q with g is x plus 3 minus 2 square root of x plus 1. These examples are found on the printed modules of our Omni kit. Let's move on to another example. Find the composition of w with r when w of x is equal to 2x squared minus 13x plus 3 and r of x is equal to 2x. Start solving this by writing w circle r times x is equal to w times the quantity of r multiplied by x. Next, substitute w multiplied by the quantity of r times x by the value of w of x. Then, substitute all the x's on the right side with the value of r of x. To simplify this, multiply 2 by 2x squared and negative 13 by 2x. After you do this, you will be getting 4x squared minus 26x plus 3. There are no like terms, therefore, the composition of w with r is 4x squared minus 26x plus 3. For this last example, let's start by solving this by writing f circle g times x is equal to f times the quantity of g multiplied by x. Next, substitute f multiplied by the quantity of g times x by the value of f of x. Then, substitute all the x's on the right side with the value of g of x. To simplify this, multiply 3 by 2x squared. Since this is the last thing in the equation that needs to be simplified, this is the simplest form already. Therefore, the composition of f with g is 6x squared over 17 plus 1. This ends our lesson for today. I hope you learned something from our discussion about composition of functions. This lesson is easy and understandable. Therefore, there is no need to overthink it. Thank you for listening.